Hey, so yeah, I think we're almost at the end. So we looked at, if you recall, first we looked at the user ID based lookup table. Then we looked at deep hash embeddings. Then in the previous video, two videos actually, we went deep into this cohort affinity based approach, where we looked at, okay, let's see the user features, and you can be more like it's up to you how detailed you want to be with the user features. You want to be very high level, like country, or add some um, past interests the user has shown affinity to, or like maybe even context features like time of day. It's up to you what you want to do with your user features. But they go into this cohort addressing layer, which essentially says which of these cohort embeddings to pick, and we do that through either softmax matmul or topk matmul, and then we go through the stack of layers and use that. Now we at the point where we're going to mix two things together. One is a general approach of based on user features, not the user ID, and a specific approach based on the user ID. And if you recall, our motivation here is that if is inspired in how humans interact with others. If you know a lot about an individual, then your conversation with them, your first message, first thing you say to them when you meet will be specific, will, will convey to them that you know them, right? Um, Imagine, on the contrary, you meet somebody who is you broadly know about them, but not very specific to them. For instance, let's say you're meeting, um, like I'm my parent, my kids go to school, and I meet a fellow parent. Then I might talk about the school because that's what we have in common. In other words, to me, this user belongs to this cohort of parents of kids who go to the same school as my kids, right? Um, if I don't know anything about somebody, then I will talk to them about even more general topics. I don't know, sports, politics, stocks, etc. Right? Weather. Um, so we will try to encode that in our next implementation, which which is also inspired by this paper from Google. It's cross decoupling network. This is the paper, empowering long tail item recommendation through cross decoupling network. I have added a picture of there from the paper here, which broadly says there are memorization parts of the network and there are generalization parts of the network. And then based on user feature, they use something very specific called the frequency. They pick which one to use. And they also show that, hey, the where is the memorization being used more and where is the generalization being used more. Okay. Our implementation is a little bit different. It's inspired by that, but it's a little bit different. So if you recall, we have two methods. One is the table lookup and the cohort lookup. The table lookup uses the user ID and the cohort lookup uses the user features. And what we are going to do is based on some activity features. Here they call it the frequency, but I think you can, you can experiment with what works. But based on a few features, we find two weights. Essentially, again, we pass them through softmax for those outputs to be between 0 to 1 and sum up to 1. That's just good hygiene here. And one of these weights essentially multiply the output embeddings, and then we sum it up. So if you go back to the human analogy, let's just say you know a lot about this individual, then you expect this weight to be higher, and hence your output will be primarily the embedding coming from your table lookup. And correspondingly, the other side is also true, that if you don't know much about them, then hopefully you capture that, hey, I should mostly rely on the cohort embedding for this user. Okay. So let's look at user mixture of representations. Again, let's look at the get user embedding function, which is what we've been doing so far. It uses the embedding table to find the user ID lookup embedding, and it uses so the superclass here is the user cohort representation. That's why I can look at the superclass get user embedding, and it, through a mixture layer, it comes up with these two weights. This is also B2, and I'll show you the mixture layer. It has output dimension 2, and then it passes it through softmax. We stack up the two embeddings. This becomes B DUT 2, and then we multiply it with the B2 unsqueezed with 1, and then we get the BDU. So this is basically a weighted sum of these two embeddings. Right. Now, in practice, when you're implementing this, I encourage you to add tensor board logging for these probabilities, the rep probs, so that you can observe how they are changing over time, how they're whether you see a pattern of them being more or less for power users. So there's a fair bit of validation analysis you could do here. Another thing I think you should do is have a dropout layer. Like if you recall, let me add it. So if in this mixture layer, yeah, in this mixture layer, I think if you add a dropout, then it will help to ensure that for each user, sometimes you are sending the gradient back to both.